to Bratati Science class. Today I'm back with chapter number 3 of class 9 science, which is about atoms and molecules. Hope you are doing great, so please stay tuned. Okay, so let's start today's topic. Well, I will be sharing the screen. I hope you can see that is the atoms and molecules, though we are doing it from grade 9 itself. But today we will be learning in details like what is actually the history of it, how does it started. All right, so this is the history. Long back, the Indian philosophers, they use the Hindi language, like, padarth means the matter. So, उन्होंने कहा था कि हर पदार्थ को अगर तोड़ा जा सकते तो उससे छोटा मिलेगा जिसको बोलते हैं अणु अणु छोटा बन जाएगा अणु को भी अगर तोड़ सकते तो उससे बन जाएगा परमाणु परमाणु सबसे छोटा है जो हर केमिकल रिएक्शन में भाग लेता है लेकिन उसको फिर तोड़ नहीं जा सकता है so after some times the in Greek philosophers they also say that yes it is the matter that we already spoke about in the last two chapters right in chapter number 1 and chapter number 2 so matter that any object that has mass and that occupy the space so every matter is made up of small particles called molecules and if we break the molecules it's further broken into atoms and these atoms take part in all the chemical reactions and it is the smallest part we cannot break it further all right so around 18th centuries it was believed that there are two laws was proposed on chemical compounds and chemical combinations the first one was law of conservation of mass proposed by Lavoisier in 1774 तो उन्होंने बताया कि लॉ ऑफ कंजर्वेशन ऑफ मास मींस इफ कोई केमिकल रिएक्शन है तो केमिकल रिएक्शन की आगे और आफ्टर द रिएक्शन देयर विल बी नो चेंज इन टोटल मास ऑफ द रिएक्टेंट्स so the total mass of reactants is same as the total mass of the products so we will be seeing for example H2 plus O2 equals to 2H2O so in this reaction, we can see that hydrogen atomic mass 1. So 1 into 2 plus 2 into, for oxygen, the atomic mass is 16. So, and this side, again 2 plus 16. So does it match? So we will see from here 2 into 2 plus 32. And this side is becoming 16 plus 2 is 18. 18 into 2, 36. See this side also 4 plus 32 and this side 36. So it is proved that yeah, if it is the water, the hydrogen and the oxygens are reacting to produce one molecule of the water. In that case, the two hydrogen molecule, and the one oxygen molecule together, they form the two molecule of water. Here, in this chemical reaction, the total mass of hydrogen and oxygen before the reaction and the total mass of the water after the reaction is same. Okay, all right. So now moving to the next one. Here you can see the second one is the law of constant proportion, which was proposed by Proust in 1779, who said that in a chemical reaction, in a chemical substance, the reactants that are involved in that chemical substance are always present in a definite proportion by mass. Now, the definite proportion by mass is important. Why? Now, if we consider like carbon dioxide, carbon plus oxygen equals to carbon dioxide. Okay, we will see what is the ratio of that. So, C plus O2, CO2, C plus O2, CO2. The carbon is 12 and the oxygen is 2 into 16. Here, C plus O2 equals to CO2. C plus O2, 12 and oxygen is 2 into 16. So C and O that will mix in always in a same ratio. C and O, the carbon and the oxygen, they are in this ratio. What is the ratio? 12 is to 16 to the 32. 32. So with the 4 3 is a 12 and 4 is a 38. So carbon and oxygen will always form CO2, where the carbon and the oxygen ratio is 3 is to 8 by mass. The ratio of carbon and oxygen is always 3 is to 8 by mass. So this is what they are saying, that it should be the reactants in a chemical substance should be in a constant proportion, in a definite proportion. This will not change in any reaction. So C and O, whenever they react, they will do in the ratio of 3 is to 8. Then came John Dalton. John Dalton said already he has he has observed what the other philosophers were saying previous to him, and then he modified and he came to the conclusion, yes, atom is the smallest element of any matter, and it cannot be further broken, which has major drawback, because we know that now atoms can also be broken to the ions. That we will come later. Positive charge, negative charge, positive ion, cation, and the negative ion, anion. Okay. So second thing that Dalton said, the atom is the smallest particle that will take part in all the chemical reaction, and a size of the atoms are so small that we measure them in their radius, that is the atomic radius, and atomic radius is measured in nanometer. So we know nano is ninth, so when we are dividing a meter with 1/9 time, that is it is 10 to the power minus 9 meter. So again, nanometer, so 1 nanometer equals to, we can write it is 10 to the power minus 9 meter. 10 to the power minus 9 meter. Okay, now you imagine, like every time we have to write calcium, like oxygen, oxygen, which is very difficult. So in that case, Berzelius, Ber, he proposed Berzelius proposed that what we will do, we have 118 elements. Okay, in a periodic table, we have 118 elements till now, where in the periodic table. So these 118 elements, if we write like this, it's very difficult. So what we will do, we will take the first capital letter of the elements. For example, sulfur. For example, carbon. For example, nitrogen. So Bajelier said that later on the IUPAC system, IPAC system, that is International Union of Pure and Applied Chemistry. So they said, let us do a modification, because if we take the first letter of any particular element, it may be repeating. So what they have suggested, that in few cases, in few elements, we will take the first letter, capital letter, and the second letter, small letter. So this is how we will create. For example, first capital letter and second small letter, like calcium. Okay, like aluminium. Okay, so that is the second point that IUPAC system has discovered. And they also said that it's not necessary it will be the first and second, but we can take the first and third. For example, chlorine, Cl. For example, zinc, Zn. So if you observe, this is the spelling of chlorine, where they have taken C and L. Zinc, Zinc. So here they are taken first and the third. Then they said that fine, but all the time we cannot take the first and the second, or first and the third. So, and we are not taking considering the English name only. So for then the Latin name can also come. For example, sodium. The name of sodium is natrium in Latin. Is natrium in Latin. So it is natrium, and for iron, it's actually ferrum in Latin. So this is how they have decided ki, that we can take the Latin name also. Okay. Next one, the C12, the atomic mass. Now we are talking about the atomic mass. The atomic mass, they are saying that AMU or unified mass, atomic mass unit. So AMU stands for atomic mass unit, or U stands for unified mass. Unified mass. Okay, so now for that we need a, when we are measuring a mass of any atom, so we need a relative measure, relative weight as well. Just imagine, like, we have to weigh the fruits. When we are going to market, we are weighing everything in a balance, in the weighing balance, where we have the two parts, and one part we have the product that we want to measure the weight, and this another one, another side, we put some weight that is related, because we know the weight, like 1 kilo, 1 kg, or 500 grams, or 250 grams, we know the weight, and then we are comparing it with the product that we want to take it, right? This is how in general we go to market and we take the products. Similarly, for atoms, we definitely there is no weighing balance, and we are putting the atoms separately. It's not possible. Atoms are very, 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 very tiny. 10 to the power minus 9 meter. Hardly really we can see. We cannot see at all in the naked eyes. Even nowadays, it's the highly electron microscopes and all, we are able to see the atoms. Okay, so they all have decided, let's take C12, that is carbon 12 atom, as the reference material, as the reference weight for measuring the weight of any other elements. Okay, so for example, the C12 was the relative weight that everybody accepted, fine. Then what is the mass of C12 atom itself? So C12 atom mass will be the 12 AMU, atomic mass unit, or 12U. Then what will be the mass for 1 AMU? For 1 AMU, that is the reference material, that will be 1/12 of it. Okay, so if 12, so this is 12. So if 12 AMU, this is the atomic mass of 1 carbon 12 atom mass. Okay, then 1 AMU will be 1 by 12 of 1 C12 atom mass, and this one AMU is the reference material. Okay, AMU. So 1 AMU, this is the relative measure. So what we will put it here. Okay, now it's seen that in if it is possible in real life to have a weighing balance, and one side we are putting a molecule of hydrogen, then 1 AMU with 1 AMU only, it will be balanced. Okay, but in case of the oxygen molecule, we need 16 AMU. We need 16 such weight to balance it with oxygen. So every atom has the different AMU, a different atomic mass, which can be relative, which can be compared with the 1 AMU of carbon 12 atom. Okay, done. So next question is, how do in nature do atom exists? Like, we know that atoms are very small particles, then how do they exist? They can be separately, but most of the time they form the chemical bond or the force of attractions with the other atoms. And different atoms, they combine together in a chemical reactions with the chemical bond, and they form molecule. So atoms are present either in singular, that is separately, for example, hydrogen atom, and in a molecule of hydrogen, that is a similar atom, like two hydrogen atom will be together to form one hydrogen molecule. Monoatomic, diatomic. Monoatomic, diatomic means in one molecule, one atom is present, and in diatomic means in one molecule, two atoms are present, and triatomic is in one molecule, three atoms are present. So we will see that. We will see the examples also. For monoatomic, take the noble gases, like we can write the helium, we can write neon, we can write argon, and for diatomic we can write oxygen, we can write hydrogen. For triatomic we can write ozone gas. For tetraatomic, we can write phosphorus. For polyatomic, we can write sulfur. Okay, so these are the few polyphonic, polyatomic, diatomic, okay, triatomic, monoatomic, etc. Then, according to the law of constant proportion, that is the second law, the different atoms are present in the definite proportion by mass in a molecule. And we can calculate the mass of a molecule by calculating the mass of the atoms present in it. What we need to do, we need to add the mass of the atoms to get the molecular mass. Okay, so how it is possible? So here comes the two concept, that is GAM, that is gram atomic mass, and GMM, that is gram molecular mass. So gram atomic mass and gram molecular mass. These are the two. It will come. Now calculate the molecular mass of a compound CO2. So CO2 here, one mass of carbon plus two mass of oxygen. Okay, so for one mass of carbon, that will be 12. One mass, carbon mass is 12, plus 2 of oxygen, that is 2 into 16. So 12 plus, so what I'm saying, that carbon, the molecular, the atomic mass, we know that carbon C12. So atomic mass of carbon is 12 AMU, and the atomic mass of oxygen is 16. So here what we are doing, one carbon, that's why 12 plus 2 into 16, as it is O2, equals to 44. So this 44 AMU will be the molecular mass of one carbon dioxide. One molecule of carbon dioxide equals to 44 AMU. But in case we want to make them in gram, then we will say that 44 grams. Like if we want to say that the molecular mass of carbon dioxide is 44 grams. Okay, so ions, we already told that one, what John Dalton has said, that atoms are the smallest particle, it cannot be broken further. Actually, we know that in atom we have the three different types of ions. Like we have the protons. The protons are the positive charge. We have the electron. The electrons are the negative charge, and the neutron, and the neutrons are the zero, that is no charge, null. Okay, now generally in one act, in one, atom, when the atoms is there, so generally they are neutral. For example, Ca is neutral, so that means plus and minus are in equal amount. Now if it is giving two electrons or one electron to some other atoms, because they are doing the electron sharing or electron releasing or electron accepting, they can do that. They can either accept or release or share their electron. So calcium is sharing one electron, so obviously it will be plus. It is now plus charge because it has become positive, because the negative charge is gone. Similarly, if X is a molecule, if it's an atom, X is a neutral atom, and it has gained an electron, so plus E, so it will be minus charge. So this is how we can just check that whether an atom or it is a cation or anion. Now cation and anion, I was telling you, cation is the positive charge and cation is the positive charge ion, anion is negative charge ion. Next concept is valency. Now, why do the atoms, they share their electron or they exchange the electrons, like releasing and gaining? So the main reason is all the atoms want the stability. Okay, stability in the nature, stability in the surrounding. So what do? They exchange the charge they have present to combine each other and to gain the stability, and that is called the valency. In next chapter we have a details of it, that what is valency and how to do it. Okay, so now chemical formula. Now we need to find out, we know the symbol, the IUPAC system has already done it for us, but Julius has started it. Now we need to go with the chemical formula, and that we do it by exchange of the charges. So there is a concept of, like, for example, how to find out the chemical formula. So for example, I'm showing it here, like calcium carbonate. So Ca2 plus and CO3 2 minus. So what we will do, we will exchange their charges. So actually it is going to be minus, and here CO3, here it's going to be plus. So what we will do, we will nullify the charges, and 2 and 2 also we can nullify. So actually it's becoming as CaCO3. So this is how the chemical formula of a molecule is formed. Calcium carbonate. Now sulfur oxide or sulfur dioxide, we have S and O2. So sulfur and oxygen. Okay. So like SO2. So that what we will do, we will again change it. So negative charge and positive charge, we will nullify, it will be SO2. Or sodium Na plus Cl minus. So here Na plus and Cl minus, that will be exchanged, and ultimately it will be NaCl. The charges will be, the neutral charges will be nullified. So this is how the chemical formula is formed. Okay. Now the concept of the mole. Okay, I missed that 118 elements. Out of that, in a periodic table, learn at least 20, because it may come with your the number of the proton, number of the neutron. So the number of the proton is always, we write it down, and the number of together proton and neutron will be there on the top. That is the total of the proton and neutron. Now, in few cases, in few elements, like for example hydrogen can be present in the same proton but with a different neutron number, like H11, H12, H13, etc. Like H11, protium, deuterium, tritium, etc. So these are called the isotopes. And like that, when we have the same mass number, but the different in their like calcium and potassium 40, and calcium also 40, but here 19 and 20 the proton number, or the so this is how these are called the isobars. Okay, isobars. So this is how we will be learning isotopes, isobar and isotone in the next chapter in detail. That just I said what are these and how to write a chemical formula. Next we are moving to the mole. The mole is also a unit for molecular weight, like we know that kilogram. Okay, like that mole. So whenever there is a mole concept, the mole is nothing but the gram atomic mass and the gram molecular mass we will be learning in the mole. That is the amount. It is also a measuring of the weight of the atom. Now, what is Avogadro constant? Number of atoms or molecules or any particle present in 1 mole of any substance is always constant. So in that 1 mole of substance, any substance, it can be the book, pencil, etc., non-living, living objects, any objects, 1 mole of substance contains, 1 mole of substance has 6.023 into 10 to the power 23 number of what, number of atoms or molecules or particles, whatever it is. So this constant number is the Avogadro number. So that means 1 mole of hydrogen atom will have a mu, 1 atomic mass unit, or 1 u, which is equals to again the Avogadro number. And this is how the sums come, and based on that, so we have to remember two formula based on the numerical when we are finding out the small n numerical, that is out of given by mass, that is the mass based on mass and based on the numbers. So based on mass, it is going to be small n is small m by capital M, where small m is the given mass and n is the molar mass. So in sum, in a problem, they will be giving you all, m will be given, n will be given, then you can get the m, capital M, or two things will be known and one thing is unknown, that you have to find out. Another option is, one is mass based, another one is number based. For number based, you have n, small n equals to capital N by n0, where n is the given numbers in the sum and capital N, this is n0, so it will be there bottom right, and these are the Avogadro numbers. So you will be given the two and you have to find out the rest. So if you remember the formula, you can easily solve the problem. Yeah. So just try to remember the first 20 elements of periodic table, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So friends, I hope you have liked today's video. You have understand something new. Okay, so please motivate me. In those who are new to my channel, you can see the playlist where class 7 all the chapters are there, class 8 all the chapters are there, class 9 we have started and this is the third chapter. So question answers and all we will be discussing later on. For first I am preparing the videos. So I'm very new to the channel, but I love teaching and my students say that I explain more good. So please stay tuned for more videos. If you have not subscribed, please click the bell icon and subscribe the channel. If you like the video, and you can share with your near and dear ones. So see you in the next video. Take care. Bye bye.